Live from New York, it's Ask This Engineer.
Hey everybody, January is over and it's now time for March 487th. And it's time for Ask an Engineer. It's me, Lady Ada the Engineer. With me is Mr. Lady Ada. As always, your friendly and somewhat goth and morose hosts who will take you on a tour of what's going on in the maker and hacking and electronics community for the next hour or so. We just wrapped up Show and Tell. Thanks to Noah and Pedro for covering for us. We just needed a little break. But they did a great job. And now we're going to kick this off. We're going to do Ask Engineer. So why don't you tell them what's on tonight's show so they can get all settled in.
All right, on tonight's show, we'll be talking about shipping stuff. We're shipping smart and safe. Shipping. Of course, this week there was a little bit of a snowstorm. So orders are making their way to you. If you place an order, thanks for being patient because there was almost a top 10 snowstorm.
I don't know if you know, but there was a blizzard.
Here in New York. Show and Tell, people around the world showing and sharing their project. Noah and Pedro did the Show and Tell this week. Lady A will talk about who's on the Show and Tell and what they shared and more. Time travel, look around, makers, hackers, artists, engineers, and more. Some news updates. Help wanted. We have jobs board, jobs.adafruit.com. You can post your skills, or if you're a company and want to find someone amazing to work with you, post the job at jobs.adafruit.com. We've got Python hardware news. We'll talk about what's in the newsletter this week.
So much.
We've got some made in New York City factory footage, including some footage of the snow, because why not? 3D printing, couple videos from Noah and Pedro. We've got everyone's favorite segment, DigiKey and Adafruit present Ion MPI. We'll have an Ion MPI this week. Lady Ada will talk about that. Got some new products. We'll answer your questions. We do that on Discord now with 27,000 makers all together. We just hit a new milestone, 27,000 people. Join us over there, adafruit.com. adafruit.it/discord or discord.gg/adafruit. All that and more on, you guessed it, Ask an Engineer.
Yeah. Okay. We're here. Okay. We're doing it.
So first up, just some housekeeping stuff. We're shipping smart and safe. We're 1 year into this. When I look at my calendar, around this time last year, we were already doing proactive measures because we heard from our factory partners in China that there was this weird thing going on. So we had already made all the plans, or some of the plans, when there wasn't any information. We had staggered shifts. We were already in the process of making sure everyone had PPE. This was before there was even recommendations. It was really hard to get information, but we had started the process in this and wanted to make sure our team was safe as possible. Here we are a year in later, and we are still COVID-free as an organization. Yay, doing the best we can every single week. And so far so good, haven't had any outbreaks or anything like that. We did have a snowstorm on Monday, so any orders that were placed right around Monday, we're still catching up, and we also have the Raspberry Pi Pico orders that we're catching up on. So thanks, our team thanks you. Pre-COVID photo of our teams. Thank you very much for supporting us all this time for the last year and more. Also, when you place an order, we are doing 100 days of masking. So there's probably about 90 days-ish, maybe a little bit less than that. Every single order in the U.S. that's basically over like $1
Yes, we have to put a
get the
number
mask.
in.
Yeah,
So one.
and so basically it's a free mask because there's really nothing that we're shipping out for $1.
And they're goth, and they're tri-layer, and they're good. And if you're going to double mask, put it over your mask.
Yeah, we all know what's next. 3 masks. So get on the 2 mask tip now before we go to 3 masks. 4 masks ahead, then 5. Then we're going to go to 7. Then pretty soon, most of us will be made out of masks. But we do have other freebies and more that we give away when you place your orders.
That's
Ada,
right.
what are they?
I'm glad you asked. When you order on Adafruit.com, we give you freebies. I love it because it's always great to get inspirational stuff, and you can always give it to people if you don't want it. I'm sure there's some maker space or someone you're mentoring that is beginning electronics who would love some of these parts. So starting from the very left over there, we've got $99 or more per proto half-size breadboard, perfect for soldering your projects onto after you're done with your solderless breadboard. And best of all, it will work great with a Pico if you got one, so you can make your Pico project come to life. $149 or more, you get a free STEM QT board. We have a collection of about 25 different boards. We'll give you a free one from that batch. If you make an account, you'll get a different one each time. Otherwise, it's just going to be random. $199 or more, you get free UPS ground shipping in the content of the United States. It's insured and trackable, and it's good. Postal service, you can use it, but we don't really recommend it. We recommend UPS. Takes a little longer, but you're going to get it. And $299 or more, you get a free Circuit Playground Express, a great way to get started with electronics and programming. You can code it up in Arduino or MakeCode or code.org CS Discoveries if you're doing that, or CircuitPython, or I think even like MicroPython supporting it soon. So all good stuff, free when you order from Adafruit.com. And at every level, you get the previous ones too. So load up.
Okay. Next up, we have show and tell. We do that every single week. We've been doing that for a decade. We're going to try to rotate our team out even more because some weeks running an Adafruit and trying to do all this stuff at the same time. We have an entire team, so we should figure out ways to have our team run the show and tells with us. So thanks, Noah and Pedro. They hosted it this week. Lady Ada, who's on the show and tell? What they share this week?
Yeah, well, Noah and Pedro didn't show anything because they were hosting. But maybe in a week or two they will catch up, and we'll also show off the projects they've been working on. We had Kevin from DK come by and show off the Circuit Sculpture Calendar. I think they're giving away some on social media, so check out DigiKey on social media. Melissa wrote a guide on using Home Assistant with ESP32S2 and how to do that by installing CircuitPython and Mini MQTT. So you basically make a Mini MQTT client for Home Assistant with the ESP32S2 and have it work with Home Assistant flawlessly. So she already had an install. She got a temperature and humidity sensor going, and it's totally solderless. There's a STEM QT connector on the Metro ESP32S2, so she just plugged in a sensor and it got it uploading perfectly. We'll show off that guide shortly, but great if you want to combine CircuitPython and Home Assistant. Erin showed off her Princess with Power Tools calendar. It came out. She's in it. A lot of awesome scientists and technologists are in it, dressed up like princesses, and how could you not love that? She also did a guide this week on a cosplay floating LED fireball, so it kind of looks like it's levitating in your hand, and it can react to motion or sound, all in MakeCode. It's a great cosplay prop project. From the community, we had Mike D come by, and Mike D got a Fona and a Metro and has been in the basement all this time, working on projects, learning stuff, getting creative with electronics, and made a rotary cell phone that you can call, and it'll ring the phone and you can pick it up, and it acts like a phone basically. But he's gonna, when he can go to bars, he's gonna take it to a bar and put it on there, and people can call him on the phone, and it rings really loud. Great job. That's a really fun, popular project. Next up, he wants to add a thermal printer, so when you SMS him, it'll print out on a little piece of paper and you can rip it off. I love it. So Mike D's super cool. Travis the Maker is back, launched his Kickstarter for the Build Your Own Keyboard. Check it out on Kickstarter. It got funded. It's using Itsy Bitsy M0, so you can code up your own mini keyboard in Arduino or CircuitPython. He's giving away some. They're doing buy one, give one. They're trying to keep it low cost, but if you want to go back that on Kickstarter, check it out. And if you do have a Kickstarter, we don't post Kickstarters, but you can come on Show and Tell and promote your own, and that's fine. So he did that. Good work, Travis.
Yeah, there's some exceptions. If you're doing Adafruit related stuff, and it's a project you've shown on the Show and Tell, We've done posts.
Yeah, but in general, we recommend.
Yeah, the reason we don't is because there's a lot of
promises.
well, also kind of like what happened to social media, where it just becomes like influencers, and with Kickstarters, a lot of them turned into like failed hardware businesses, and so we try to only feature ones that we have an idea. The maker has come on and done a video, talked about it, showed like real working hardware, and relatively safe bet.
Yeah.
So folks don't get disappointed, because for a while there was like renderings of like the
Remember,
latest
like
thing.
the toothbrush thing? There was like the laser shave thing.
There was
Man, it was fucking
everything.
weird.
Then they migrated to Indiegogo. Then they kind of disappeared. Or like the shields are up right now for the most part. I think people have a pretty good detector. They've moved on to like crypto stuff.
Yeah.
Yeah.
That's true. It's all
Yeah.
moved to crypto
Yep.
stuff. Okay, and that was your history of the internet. Liz is working on a Raspberry Pi Pico MIDI controller, and Mark is contributing to CircuitPython by adding parallel bus display support, so like 8-bit buses or maybe even 16-bit buses for really fast display updates. He's adding that to the RP2040. Thank you, Mark. It's awesome to see people contribute peripheral support to CircuitPython for their favorite chips. It really gets more projects possible. We got the RP2040 definitely up and running, but if people want to contribute, we're trying to get contributions in, and it's great. And that was Show and Tell.
Okay. It's part of our Adafruit live series of shows. If you're watching this right now, it's Ask an Engineer. It's 8 p.m.
Yes.
Show and Tell is every Wednesday at 7:30. Those
That
are our
happens.
Wednesday shows at night. Show and Tell. Ask an Engineer on Sunday. We have Desk of Lady Ada. This week on Desk of Lady Ada, we showed some new samples. We had these really new cool NeoPixel stuff.
We got some cool NeoPixel samples.
Yeah.
I'm always getting new ones, and I can't help it. I just love them all.
So check that out.
Yeah.
And then
like
we
double
also...
LED strip and like pre-addressable strips. I don't know, all sorts of cool stuff.
Yeah.
Where in the world is that part I need? The Great Search with DigiKey.
And then we did the great search. We do that with DigiKey. It's Lady Ada using all our powers of engineering to show you how to search the ginormous side of DigiKey. And what did you look for this week?
All right, this week was SD card holders. So that's a common thing people need. And I showed off a couple different types that I've used or I've seen that like. Stuff to watch for. Adding SD card storage to your project can be really easy. There's support for like every microcontroller and development environment. It has code for SD card interfacing. It's not too hard. CircuitPython, Arduino for sure, and MicroPython for sure, and every C SDK. But you'll definitely need a good SD card holder to hold that SD card. But once you do, you can have like gigabytes of storage for like $10. What an awesome idea! Great for data logging projects. So I show some tips and tricks and some models of SD card holders you may not have seen before, all on the Great Search.
So that's Sunday, usually around 8 or 9 o'clock. And we do What's on Lady Ada's Desk, as hence the name, Desk of Lady Ada. And then we have a great search. Tuesdays, we do JP's product pick. And here is a recap from this week. You can tune in every Tuesday. We broadcast
What's this
live.
graphic? We're like
Yeah.
getting weird.
We broadcast live from a product page. And we have deep discounts just for that period of time. I think we're the only electronic company, or any company, that does that right now. In other countries, specifically like Taobao, Alibaba kind of land, they'll do stuff like this, and that's where we get the idea from. So take it away, JP. Here's a little bit of highlight.
The DS 1841 log digipot. This is fantastic for any time where you want to be able to change the volume using either software controls or some other non-mechanical sensor to adjust volumes. Then you want to introduce this into the mix. I've got a little clock radio, and I opened it up and I ran some wires to the internal volume potentiometer. And I have grafted the DS 1841 into there. It's running over a Stemma QT cable to this Metro, which has CircuitPython running on it. It is the DS 1841, and it is a great digital substitute for a mechanical potentiometer for audio applications.
And coming up on Thursday is JP's workshop, when you can see the latest things. We have a bunch of cool Pico stuff coming up ahead. And we also have a Make Code Minute that you can watch either real time on Thursdays, or you can catch up, and we're going to play that one right now.
For the Make Code Minute today, I wanted to talk about a brand new feature inside of Make Code Arcade. I've loaded up one of my game picks of the week from the past, which was this Mini Galaga game. We're not going to look at the gameplay, and we're not going to look at how it's coded, but we're going to look at this really terrific new feature, which is the asset browser. So you'll see here up at the top, we have the blocks interface, we have the JavaScript tab, which you may be used to seeing those two, but here's this new one, assets. So what I'm going to do is, let's just go ahead and hit that assets. So here you can see this is a list of all of the assets in the game. These are sprites that have, or backgrounds that have been used inside of the game, and you of course can always find them inside of blocks. So if we switch over to the blocks view, they're going to be in here. There's the background sprite. Here is the ship player sprite. And as you can see by my dramatic representation of this, it is actually a little bit of work to surf around finding the assets if you want to go and change one. So now this asset browser allows you to go in very quickly, pick, let's say we want to change the color of all of these green meanies. We can just click on the asset in the asset browser. We get a little asset preview, tells us some info about it, the type of asset it is, the size in pixels. We can duplicate it here, copy it here if we want to make a variant on it. This is a really convenient place to do. We can also just pop the sprite editor right open. So this will make it really quickly to go through and make some wholesale change. Let's say it's just going to be pink baddies. Done. That just saved that asset. We could, of course, copy it first if we want to use them in different ways. So this is really terrific. As you know, some of these games can get pretty big, pretty out of hand. You can have lots and lots of assets. I've picked a fairly tame one here, but open up one of your favorite games in Make Code Arcade and head to the Assets browser just to take a look and maybe to edit some of those sprites. And that is how you can open up the new asset browser inside of Make Code Arcade. That's your Make Code Minute.
Okie dokie, so tune in tomorrow for JP's workshop. All right, time travel. A little bit of news.
I feel like I'm time traveling all the time, but I'm like in molasses time.
There is. So time travel this week, just a little bit of a reminder, we're going to be shipping the next Ada box in April. So we don't have tons of openings. If you've been on the fence, we will run out because we're going to start doing promotions probably in March. So if you haven't
I'm
already...
getting started with it.
Yeah.
But it's going to be a good one. If you signed up, stay signed up, because if you leave, you're not going to be able to get your spot back.
Yeah. Other bits of time travel news. This is Black History Month. And if you go to the Adafruit site, we have at least a few posts a day celebrating Black inventors, scientists, engineers, artists, musicians. You can go through and look at not only this year's posts, but all the posts that we do every single year. We've been doing this from the start. This is from the Adafruit team, and this is something important to us. So check it out if you're at a company. This is a good month to celebrate others. March is Women's History Month. We'll have stuff then. And in April, there's also... we have to look at our calendar, but there's always a month where you can celebrate someone. So this month in particular, check out not only the current things in the month, but look that we've put throughout the rest of the year, like businesses that you can support.
Yes.
So all of it's there, and then you can also go to adafruit.com/Black Lives Matter, and you can see all the things that we put together as a team over the last year as well. Next up, let's go to our jobs board, jobs.adafruit.com. We're going to fix the economy. Someone's going to do it.
Slowly but surely.
Go to
There's
jobs. Yeah, go to jobs.adafruit.com. These are some of the ones that we had featured that I just want to do another shout out because they're pretty high-level roles. Executive Director for the Open Source Initiative, the OSI, Director of Resource Development at the Python Software Foundation, and a Community Game Designer at Hack Club. All those are available right now. Apply for them And you can also post your skills if you're looking to get your skills out there so you can take on some cool work.
A lot of it's going to be remote too. So good time. And you no longer have to worry about whether you're in the same city or state.
Yeah. All right, next up. It is Python and hardware news.
It's the Blinka news. Beep,
All right.
beep, 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 beep. Blinka.
The news this week,
Okay.
the talk that you did is posted.
Yes.
So this was the Linux AU.
Okay, so everyone who's like, why did CircuitPython fork? Why did you do Blinka? Why did you make all these decisions? These are bad decisions. I think they're bad decisions. There may be a reason behind the decisions. You could watch this talk and I will explain from beginning to end the story of how CircuitPython and Blinka came to be and why I made some decisions. We even got an
Yeah.
email from somebody saying, which we've known for a while, and he's like, I never really understood why CircuitPython had to fork. And they're like, I watched this and I actually understand why you did it. So check it out. It's also a great history of like all things microcontroller and electronics packed into 1 hour. And I also serve up duck 3 ways at the end.
All right. This is kind of neat. These are the die shots of the Raspberry Pi
Look
RP
how cute
2040.
it is. It's
Yeah.
a little mini Raspberry Pi logo.
So you could start to see the insides of
I love it. You're like zooming in.
the chip.
Cool. Nice.
Yeah. That can run Python.
That's right. That's
Yeah.
literally Python on that hardware.
Literally Python and hardware. Another reminder, 27,000 people in Discord. Some of you are there right now. We have 4,528 people online right now. Scott's Deep Dive is this week. Don't forget that. News around the web you can check out. Melissa's really cool. It's like a little personal digital assistant, a CPDA, CircuitPython digital assistant. It runs on a Adafruit Pi Portal Titano and does things like calculator, has little icons. Reminds you of the Newton and the Palm
Love it.
and the Magic Cap OS.
Remember we went and saw the Magic Hat while we were working on
Yeah.
PyPortal. I think was when we went
Yeah.
to watch the Magic Hat documentary. Remember we
Yeah.
were watching movies?
Yeah, I remember the movies.
That was cool.
Geek have a couple more projects. We also released a guide. You can see this is
Maskbot.
Professor G's mask launcher or mask giver. This is kind of neat. The circuit sculpture hobby comes to the Pico, and this is CircuitPython and circuit sculpting with CircuitPython powering it. Here's some more Pico projects. This is
MIDI. So that's a good
this is the
idea.
MIDI stuff. Everyone's checking out
Stonks.
and GameSpot. And if you want to use and make the easiest possible stock ticker, you can do it with CircuitPython in a matter of minutes. And so, like, if you wanted your own stock ticker, if you're like, okay, like I'm gonna just check out this trend today, or I'm on Wall Street Bets tomorrow, or I'm gonna use Robinhood now. Like this is a way to do it.
It's a great way to see your money disappear.
Yeah.
But in CircuitPython.
And here's a OSC device using Sonic Pi and Raspberry Pi Pico. The ADC reads CircuitPython slider, allowing the pupils on the dinky OSC to move all around the eyes.
It was a really cute project.
Yeah. Pimeroni.
Lots of people doing
Pico display.
MicroPython.
Yeah. So Pico's making the rounds. You can see a bunch of tutorials and more. Folks are diving right in, getting their Python on, and then programming microcontrollers. So this wrap up week that we did has a lot of MicroPython projects, a lot of CircuitPython projects. You can use these with Pico. One of the cool things with CircuitPython, of course, or really what's Python, is you can take the code, move it around, and it works
Yeah.
other places. Other guides that we publish, team notes, and more. We're up to 290 libraries. You can see what each team member is up to on the team, what we're publishing, what events are ahead, and more. And that is Python on Hardware News for this week.
It's been massive. And this Pico launch is just going to, there's now thousands and thousands of people that now have a board that runs MicroPython, CircuitPython. So I think we're going to see a ton more projects, code, contributions. I'm super psyched.
Yeah. And the whole idea is, and this is the thing I like about electronics right now, is you have choices because you can boot up as CircuitPython. You can use it MicroPython. You can use
You have
it
two
in C++.
built in, so it's
Yeah.
like trivial. Oh my God, I love that. It's just like drag and drop. it's like exactly like the next generation. It's perfect. So
Yeah.
a lovely new microcontroller. I'm enjoying seeing people. You know, like it's funny. I mean, like I think eventually there'll be Arduino 4, and that's really good. But I kind of love that people are sort of being forced to use MicroPython and CircuitPython, right? Because it's like that's the way you can do projects. And I think we're going to see people kind of being pushed to use something that a lot of people are like, I've never used it. I don't want to use it. I'll use Arduino. But now they're kind of like, well, I got to use MicroPython. That's the official language.
Yeah, and
Cool.
for a lot of folks, they're like, they start off with what this is a good segue into our open source stuff. They start off with, I just want to move a servo, and we made it so easy that gets them going, and then they can use other stuff later. But like CircuitPython gets you going in a matter of minutes. It's one of the programming languages we like to use. We work on and develop it. We have 2,412 guides this week.
Yeah.
A bunch of them have to have CircuitPython. What was on the big board this week, Lady Ada?
Yeah, we launched a lot of guides. Last week it was, a couple, but this week we got 6 new guides. Okay, well, last week we had the NeoPixel Crystal Chandelier with CircuitPython that Aaron did, and the AI Freezer Monitor by Adi. This week we kicked it off with a no solder visualizer capacitive touch controller. So JP installed like this processing app. And this is like a really common, honestly, a thing at the Media Lab is people would like make these really cool visualizers or art projects, but then they'd want like some way for people to interact with it, sort of like a museum exhibit type thing. And that was actually the really hard part. So I thought like, let's just show how you can plug and play, no solder. And a lot of the projects that we're starting to publish are no solder, which I love. So this is a no soldering visualizer where we use STEMMA QT to plug in the capacitive touch board into a QT Py using a cable, and then copper tape to make the capacitive touch pads, and then you just print it out on a color printer, this like wheel, and you touch each pad, and it makes the controller. We have a guide for the new SPI flash SD card. Can't read what that up. It's an SD card. It's a chip. It's an SD card on a chip. I don't know. It's cool. People really like it. It's great for data logging or high vibration, high stress situations where you're worried that the SD card's going to come loose. Don't have to worry about that. Deborah did a beautiful, beautiful guide on this infinity mirror collar. She made a bracelet and was like, hey, I'm thinking of doing this bracelet. I said, you know what? I think a collar would look so cool, right? Because it would be kind of this robo cyber thing. So now she has a collar and a bracelet, so that's cool. And she posted also some video on her Twitter. But using side light neopixels and this vinyl that is like translucent mirrory, you can make like wearables that have a infinity mirror effect. We also have from Carter RGB matrix portal room CO2 monitor. This is actually because we saw so many people. I wanted to show this off. So many people were doing projects, and they wanted to do CO2 monitoring. Sorry, let me grab my.
Yeah, so one of the things that we do at Adafruit is we make sure we have really good airflow. And one of the things that we're installing are these. We know our airflow is really good. It's one of the reasons that I think that we've managed to stay safe. Everyone's really far apart, but they're also in like really high ceilings. We have cross airflow. We have filtered air coming in.
This is actually really flickery.
And
But,
we're not recirculating the air.
So this one, it's just flickering because the power supply's not that good. But you can see that it has a smiley face. Why is it so flickering? And when I breathe on it, oh man. You know what? Let me demo this in a. Sorry. I apologize. This is not looking good. But check out the video. Live demo. Oh wait, you want me to try this?
Yeah, why not? I don't know if that one works better.
Oh, yeah, much better. Sorry about that. Your computer's like, hey, you plugged in a board. Sorry, so I just breathed on it, so it's like warning the CO2 is really high. But if you hang this up, what we wanted to do is make a project that classrooms could have, because we were hearing from people that are like, we want this in our workplace or our classroom or like, a hall or someplace where a lot of people, a cafeteria, places where people gather, and we want to monitor the airflow, and CO2 is a really good way of doing that. So when your CO2 level is under 1,000 ppm or 800 ppm, that means that there's enough airflow that the human breath isn't building up. But if it gets too high, if it gets over like 1,000 or 2,000, you probably want to open up a window. So for folks that, especially it's really cold up here, if you're in a cold area and you want to open the windows to get circulation, but you don't want to open the windows so much that everyone's freezing. This can be a really good helper guide for, whether you're getting enough ventilation indoors. So good job, Carter, for making. I think the simplicity is what makes this project so cool, in my opinion. It's like it just does what it does. It doesn't do anything else, and it's also a no solder project. You can just plug and play it to make a true CO2 monitor. We've also got. I just love that project so much. Thanks, Carter, for doing it. We also got the cosplay floating motion LED firewall. We have a little video that will play afterwards with it. And this is cool. This was kind of based off of a project that a bunch of Etsy sellers have been making. So Aaron was like, I want to do this, but I want to make it like not just glow, but actually have like a fire effect. And then when you move your hand, it flickers, or when you shake, or when you make a sound, it lights up. And it's all in make code, so it's really easy to do. And then Melissa did a project, like we mentioned, with Home Assistant, how to use CircuitPython to make a temperature and humidity sensor that sends data to your Home Assistant install. So it can be used for little sensor nodes, and you can even go to deep sleep modes to save power. So yeah, there's quite a few no solder projects this week, which is good.
Yeah.
No solder, no Arduino. Love it.
We have a video from Aaron.
Yep.
Alright, some main New York City factory footage.
I always love how Aaron's living her best life.
Near.
This is the SHT4. This is in the new board, and
R.
they were like, hey, we always QA the sensor, and they're like, this sensor is so small. I said, yeah, but it works great. This is it. Like, and they got a photo of it, so I could QA the. Okay.
Then we had
Thanks,
some.
Elmo.
Then we had some weather,
It's cold
and
snowy.
it was snowy, and wouldn't be factory footage without some Soho
Soho snow.
And here's some of the snow coming in. And
It was a blizzard.
yeah, it snowed a little bit. Disney got snowed in. So they dug a big hole now.
It's starting to look a little bit like the wall from Game of Thrones. Like,
Yeah.
okay, look, they're like, we gotta dig away the snow.
And that's the factory footage for the week. All right, 3D printing. We're going to play these back to back. We got the heart shape PCB, and then we have a speed up. Take it away, Noah and Pedro.
Okay.
Hey, what's up folks? In this project, we're making a glowy LED heart with Adafruit's Cutie Pie. This is a simple PCB with NeoPixels that we designed and CNC milled. We made it as a beginner-friendly PCB for folks who want to practice SMD soldering. The Cutie Pie dev board sits flush in the center and features a cutout for the SPI flash chip. To make our PCBs, we used the desktop CNC mill from Bantam Tools. I really like their software because you can easily drag and drop your CAD files. We designed the PCB in Autodesk Eagle and created a custom footprint for the Cutie Pie. This was routed for a single layered board and features pretty chunky traces. The width of the traces are set to 0.6 inches, so they'll work well with a 132-inch tool. I made the SMD pads for the Cutie Pie a bit wider so they're easier to solder. I used the footprint for the NeoPixels from the Adafruit Micro Builder library. Routing for a single tool keeps it simple and it helps reduce machining time. These single-sided FR1 blanks from Bantam Tools are pre-cut so they'll fit on the spoil board. The 132-inch flat-end mill is my go-to tool whenever I'm milling PCBs. Using a fan bit keeps the dust away, and it's pretty handy if you're doing any sort of filming. End mills are secured to the collet, and the machine has a probing process that checks the tool's Z-height. I was able to fit 4 PCBs on one sheet. You can get the most out of your material by placing your boards closer together. To secure the PCB blank to the spoil board, you can use double-sided Scotch tape. I like to use wide tape because it gives you more coverage. Just be careful the tape doesn't overlap. The PCB is lined up with the lower left corner of the spoil board. Material can be warped, so I make sure to press down firmly and wipe the surface clean. After going through your internal checklist, get ready to start milling. While cutting the outline, the fan bit got loose and flew off the end mill. Scary for sure, I let the machine go instead of hitting the emergency stop. Thankfully, this didn't affect the cut, so I just stuck it back on and the tool persisted. After milling, I made sure to inspect the traces and the board outlines. To get rid of all the dust, I like using a handheld vacuum with this tiny tube attachment. To remove the PCBs, you can use alcohol to soften up the adhesive so you can easily pry it off. I'm using a razor blade, but a thin spatula or a palette knife would work just as good, if not safer. I was able to remove the PCB from the spoil board in one piece, which is pretty ideal. After some cleanup, the PCBs came out really nice. All 4 of these came out pretty clean, so we can get them ready for soldering. They only took about 10 minutes to machine, which is pretty impressive. We'll get the Cutie Pie ready to solder, but first let's get the SPI flash chip soldered onto the back. Use the marker on the solder mask to get the ground pins oriented correctly. I'll tin one of the pads first to get one leg anchored to the PCB, then we can adjust it. Heat up the single pin and then you can reposition with tweezers to correct the placement. Once the first pin is in place, you can add solder to the tip of the iron and carefully brush it onto the pins. I was able to fix some bridging by heating up the solder joint and removing it with a clean tip. Reflow if you need to, just be sure to frequently clean the tip of the iron. Once all the pins were soldered, I thoroughly inspected each of the pads. Next time I do any SMD soldering, I'll try to use some flux. I added a piece of Kapton tape over the power and ground pads to avoid shorting anything out. I secured the PCB to a stick vise and placed the cutie pie on top in the center. Check the pads on both sides so they fit evenly spaced apart. Castellated pads on the cutie pie make it easier to surface mount. After the first pad is soldered, the rest gets easier. To get the most mechanical strength, I flooded the through-hole pins with some more solder. I made sure to thoroughly check the solder joints are fully touching the pads. After that, it's time to solder up these neopixels so we can take them out of the tape reel. Place the first neopixel using the corner marker to note the ground pin. I used my phone to reference a screenshot of the design so I could correctly orient the LEDs. Similar process, tin the tip of the iron and add a small amount of solder to the pads. Once one pad is anchored, the rest gets easier. Once again, making sure to thoroughly inspect each pad on the pixels. You can use a 5V USB battery to power the cutie pie with a USB-C cable. It's running CircuitPython using the LED animation library to make them pulse red. I hope this inspires you to make your own PCBs and get into SMD soldering. Thanks so much for watching, and don't forget to subscribe for more projects from Adafruit.
And you can catch Noah Pedro every Thursday.
I love like this.
Sorry, every Wednesday.
The mittens are already 3D modelable. You can now
Yeah.
burn it to any project you wish.
Every Wednesday, 3D Hangouts. So and then tomorrow is our 3D Thursday groups of posts and more. All right, next up, DigiKey and Adafruit present. All right, this week's INMPI is from Diodes.
I know. Well, first up, I want to say they do make diodes and they make great diodes, but they also make things that are not diodes. And I feel like Diaz Incorporated, they don't get enough love. I mean, they're not one of like the big 5 semiconductor companies, but they do make really good stuff. In fact, our favorite regulators, our power converters and regulators, are from Diaz Incorporated. So I do want to give them a shout out. And so when I saw this product show up on digikey.com/new, I was actually, and some people are like, oh, like, do people like, are you told what to put on INPI? No, believe me, the things I picked, these are things I'm actually personally interested in. And you're going to see this chip appear in a lot more of my designs because this chip is awesome.
Yeah,
Okay.
This is how we decide.
This is how I find more
This is how we decide on what things we're going to put in our products.
Right. So the AP63300 and 001, which looks like this, very exciting. It's a TSOT6. What is it? I'm glad you asked. Here is a leaflet from Diaz Incorporated, which kind of covers everything. New product announcement. This is a 3 amp, low quiescent current, synchronous buck converter with great EMI performance. But let me tell you what's awesome about this buck converter, because I use low dropout regulators all the time, and even somebody asked me, I think on the last Desk 88, they're like, why don't you use buck converters or buck boost converters instead of a low dropout? And I'm like, well, usually there's a big price difference or a cost difference. So here's what's really cool about this series. So this is a table with a couple different chips on it, but I'm talking about the two ones at the top, the 6300 and the 63301. Okay, so the first thing that's awesome about these is the input range. It's 3.8 volts to 32 volts. So like you can put almost any voltage in here. Like this is great. You can run off lead acid batteries. You can have it work in a vehicle. You can have it run off of like solar panels. You can run it off like anything, right? Alkalines and up. The output voltage is also a very wide range. It can go from 0.8 volts, that's the lowest, up to VIN. And when it gets very close to VIN, it actually kind of makes the chip turn into a low dropout regulator. But you can read about that in the data sheet. Basically just 30 volts, up to 30 volts input, up to 30 volts output. So this is great because a lot of the buck converters that we've seen are like, oh, maxes out at 12 volts or maxes out at 6 volts. This one, it's like pure range, right? I've never even used more than 24 volts in any of my designs. So this is great. Good if I know there's people who are like, I have robotics projects. I want to have a buck converter for my robotics project, but I have 14 volts in or something. Not a problem. Or 28 volts in. Number 3. The A out, 3 amps continuous. Love it. And you don't need any external MOSFETs or diodes. It's synchronous. So all you need is a couple passive components, and we'll show that next. There's 2 versions, and I'm going to chat about the 2 next versions, why there's an O1 and an OO. There's slightly different operation modes and quiescent currents, and I'll explain that shortly. But let's show off the typical application circuit. Again, I love it. You don't need any external components. There's even a little boost converter thingy inside, booster for the high side FET. So that's the C3 capacitor. Input bulk cap, output bulk cap, voltage divider, feedback loop with a little feedback cap, a little mini cap there just to stabilize it, and your big inductor, and you're done. That's it. There's even an enable pin. Love it. Like I said, goes up to 3 amps. There's going to be differences in the efficiencies when you're talking about lower current. Lower current, less than 100 or 50 milliamps. So this is if you look at the bottom, it says the AP63300, which I'll just call the 300. So the 300 has good efficiency pretty much across the board. You can see here like various VINs and VOUTs. You're always going to be basically looking at, 70 to 90% efficiency from a couple milliamps all the way up to 3 amps. This is a log scale, of course. The 301, you'll notice, has a totally different efficiency scale. Once you get below, about 100 milliamps, the efficiency plummets. So if you need high efficiency, whether it's at low or high current draw, you'll want the 300. There are some situations where you'll want the 301. The quiescent also matters. The quiescent current for the 300, the one that has high efficiency across like all the current, is going to be only 22 microamps. The 301 is, I think it says 280 microamps, 200-ish microamps, so a lot worse quiescent, pretty high quiescent current for the 301. So you're probably like, well, wait a minute. So the 301 has a much higher quiescent and is much less efficient at low current. Why on earth would I want that? The reason you would want that is this is the 300, right? So the one that's high efficiency, low quiescent. And what I want you to look at in specific is in the top right, you've got that V out ripple. So this is the ripple at low current, right? That says, I think, 50 milliamps. So you'll see that this version of the buck converter changes the way it does the PWM output. The frequency plummets to get better efficiency at low current, but it's a lot noisier. You see that range there it says 100 millivolt per division, whereas the one that is fixed, more fixed frequency, and you can see the top right. The graphs are not in the same location, so just be aware. The frequency is in the top right. You see the frequency stays stable, and because of that, the output voltage ripple is much, much lower. So basically, use the 300, you're going to get better efficiency at low current, and you're going to have a lower quiescent current across the board. But if you have, if you're doing a lot of low current stuff under 100 milliamps and you need low noise, this might not be good for you. They're pin compatible, so you can switch and swap. Start with one, try the other. There's an eval board. I even picked up an eval board. I just love the simplicity of it. It is a TSOT chip, which is kind of weird. You might be wondering, like, well, how, it's doing 3 amps with internal MOSFETs. How is it dissipating all that current, that heat from that current draw? Well, first off, the internal MOSFETs are pretty low. I think they're like 75 milliamps. But also this PCB has 2 ounce copper, and you can kind of see that. I'll show on the overhead too. The pads are like really big for the TSOT maybe, yeah, you want to zoom in. I'll push the zoom in. Here, near. We're always talking about near and far. So that's the T-SOT there, and you see this has it's much wider than you would expect a T-SOT to be. So it uses this for current carrying and also for heat dissipation. You see the big chunky inductor, the bulk capacitance, and then of course here's the resistor divider, and then on the bottom they have a little bit of a copper ground plane as the heat sink, because this doesn't have like a central heat sink pad, and they use a bunch of vias to help. So there's a big ground plane stitch here. Oh, sorry, actually it's not the heat sink. I apologize, I didn't read that. So that's right, that's the A. That is just like a heat sink, a large ground plane with a larger ground plane on the bottom. But the heat dissipation, I think they do talk about, they just say use 2-ounce copper and just use these big pads. So that's the only thing. But otherwise, comparatively, it's a very easy package to solder. You're never going to have any rework issues with this. You can even hand solder it if you want. So I think this is a great comparison. And then, of course, the best thing about this chip is the price. It's like 40 cents on a reel, which means it's basically the same price as an LDO. So if you're using a 780X, or if you're using a 1117 or any of those popular LDOs, you can like toss it out and use this, get it 10-20 cent inductor. You're going to have wide input, wide output, extremely high current, no heat sink required, and for the same price. So you get like better performance. You do have a little bit more noise because it's a buck converter, but overall, like, I looked, and in this class, for this range of inputs and outputs and current, this is definitely the cheapest one. And I've always had a great experience with Diodes Inc. converters. They're rock solid, even though they're like often the least expensive available. I've never had an AP2112 break on me. They've just been so solid. So I really like this buck converter. I think, don't be scared off by the fact that it has this wide input, wide output, and high current. It just means you can use it for anything. Like, I'm going to use it for stuff that is, 5 volt to 3 volt conversion, with only like maybe a half an amp of current draw. Why? Because why not? It's 40 cents. Put it on everything. Put it on your cheesecake. Give it to your kids for Christmas. Whatever. It's 40 cents. How can you go wrong? It's the AP63300.
All right, and that is this week's INPI. Very cool, unique product. Good find.
on NPI.
All right, cool. We're gonna jump right into new products.
Let's do
you
it.
ready?
Yep. New.
All right. Well, we have some revisions.
Got a bunch of
and
revisions.
More.
Yeah.
And let's kick it off.
Okay. Teeny Pico. We love this ESP32 board from Unexpected Maker. And this is V2. You're probably wondering what changed. Well, it's now single-sided. So the bottom, go to the next image. Sorry, no, that one. It's totally flat. It's even got a little bit of like an itsy bitsy like JST connector thing on the bottom there. I think it's either double-sided or 4-layer board. Oh, can you go back one? New antenna. It's a 3D Fractus antenna. Looks like super cool. I think some other things got updated. I think there's now like a reset button on the top, and it wasn't there before. But basically, it's like an all-in-one ESP32 board. Super tiny, single-sided, and it's $20. It's a great board. People love this. I think it's got like extra big flash too. But I think altogether, I love the NeoPixel or dot star there. It's a great little board for people who want to play with ESP, but small.
Okay, and also comes with
Comes with a card
and all that stuff.
and stuff. And there's LDO. There's a couple things that got updated, but the biggest one for me was like it's single-sided now.
Next up.
Okay, another revision. The stemma QTification train rolls on. Choo-choo. This stop is the INA 219. You'll notice that I'm starting to get to like really old boards, like really, original boards that we've had for a very long time. These are the toughest ones to revise because, of course, we make a lot of them. We have to do a revision process. But we revised this board so it now has stemma QT connectors. It's still the lovable INA 219 I2C power monitor, plus or minus 26 volts, I think like plus or minus 2 amps or something. You can set the jumpers on the back, but it's just like Stemma QT. It's plug and play now. Really easy to use with any of our Stemma QT boards. I plugged one of these into a Clue and made a cool solar panel monitor over the summer, and that worked out real well for me. So I'm liking it, and we'll just keep QTifying the world.
All right, next up.
Meanwhile, Pimeroni has also done some revisions. So this is their mood lamp kit. It's a Raspberry Pi Zero with like a hat on it, and it's been updated. It's actually not super visible in this one, but they've updated it to be a Pi Zero WH. So now the headers are pre-soldered. You don't have to do any soldering. And the bonnet that goes on top is a unicorn mini hat, so it has like many more LEDs. So it's like even fancier. But most importantly, there's no soldering, and the library code has changed a little bit.
All right, next up.
Next up is this pump, which we've stocked for a bit. It's a horizontal pump. It even made an appearance in AdaBox. Same pump, but now the wire is really long. You can see how long this wire is. It's a whole meter long. People were like, I want a longer wire. And I was like, oh yeah, why not? Good idea. So we just asked the factory, can you just make the same thing but with a 1 meter long cable? And they did. So it works just the same. It's just long. Okay, now we're actually getting to some new products. This is from, also, we had this in our last AdaBox. It's a whiteboard, like a flexible, thin whiteboard magnet thingy. And here's some cool art, which somebody here clearly worked at a cafe or something, because it's like very cafe art. You can draw on it with whiteboard markers. We just thought it was like kind of nice. You can cut it. It's just kind of nice whiteboard material with a magnetic back.
Okay, next up.
Okay, next up we've got from Crazy Circuits. We've got this bit board kit. So I just went straight for the kit. So what is it? I got some pictures. So this is for microbit. A microbit's not included, but you can of course pick up any microbit from us, or maybe you have one. And it's a box, and it's a very nice box. I kind of like this box, and it comes with all these little parts that if you look, like this photo is the best photo. So what you do is it's got PCBs and components that have these holes that snap directly into Lego and Lego compatible plates and bricks. And so you can actually, instead of like making a circuit board, you make like a fabric circuit board by using this conductive nylon. It comes with a reel of like thin conductive nylon, and you kind of craft your circuit using that nylon, and then if you see the holes, you kind of press fit them down, and it like snugs onto the conductive nylon to make a conductive connection. And the nylon works well with capacitive touch. It can draw current. One thing that's particularly nice about it is, unlike copper, it doesn't crack. But then you can kind of mix and match your Lego and Lego compatible stuff with microbit, and microbit comes with, of course, MIC code, so that makes it really easy to use. And you get a whole bunch of stuff. So let's maybe go over the overhead, and I can actually show.
Yeah, and I also wanted to show you get these cards. You get these.
Hold on, I gotta zoom
guides.
back out because we zoomed in so much.
Yeah, and then here.
Okay, so this is a blue LED, and you see it comes pre-soldered, and it has like these big gold pads. So this is what makes conductive connectivity with this nylon. So this is metallic nylon, which you can cut with scissors. Just don't focus. Okay, so this is blue, and then this is a little piezo buzzer, so this makes noise. This is a little switchy switch. They're all very cute little designs. Potentiometer. So all soldered. Here's a NeoPixel. So these are all, the spacing in the holes are just a little bit larger than the nubs on Lego compatible, so that you can snap it on. There's like a button, a couple buttons. There's also this like Lego-y compatible servo. These are cool. I've seen these. You get some alligator clips. There's more LEDs. This is like a very blue. This is like the bluest cable I've ever seen. Look how blue this is. Shocking. And it even comes with a little. This must be like some sort of remover. Oh no, there's a divider. And then, hold on, so this is the plates. This is a Lego compatible plate. And then, yeah, like these, like they fit on, but they're like a teeny bit loose. So then when you put the nylon in and you press it down, it'll make a strong connection. And then this is what actually holds the microbit. So for this, you don't actually put it directly onto the plate because it won't, it's not, it doesn't have holes all the way through. Instead, if you look, do you mind just going back real fast to this? I'll just explain it. You see that there's like thin 1x8s or 1x4s. You use those to lift it up. But then the rest of the components can go straight on the PCB, the Lego plate. So I think, I like that it comes with everything. I kind of wanted to start with an all-in-one kit. Great for use with microbit. You can use a microbit V1, V2. You can use a Clue. You can use whatever. It comes with some quick starts that you can use. And then I would recommend using this with MakeCode for like super easy crafting and coding.
And also check out Brown Dog Gadgets, who is the maker, distributor, and more of this kit, Crazy Circuits, Lego Electronics.
It's here.
All right.
It's Lego-y.
And start the show tonight, besides you, Lady, our community, our customers, our team at Adafruit, all the folks who help out, is...
The, oops, that's one. Sorry.
That's not it?
Next one.
Oh, that is, that's that new thing that we revised. I meant this one.
That's right. And they all look the same.
These are similar looking.
They look identical.
These are similar.
Well, but we like the goth look. Okay,
Yeah.
so the start of the show is the SHD 40. That's that little teeny sensor we showed earlier. It's like a speck of dust. So this is the 4th generation of Sensorion humidity and temperature sensors. That's the SHT. 4 is the generation. 0 means it's like the first revision. And so, of course, we stuck this onto a STEMMA QT board. We actually showed this off on INMPI a couple weeks ago, and I said, I'm totally going to make a board with this chip. What's lovely about this is, first off, it's tiny. It's very simple. It's got a built-in heater. The I2C was super easy to use, and it's got great precision. I think between like 20 and 70% humidity, it's like 1.8% accurate, and then it's got plus or minus 0.2%, so 0.2 degrees C accuracy for temperature. So it's extremely affordable. It's a low-cost sensor, even with the breakout board. Honestly, I don't think people should be using DHT series humidity temperature sensors anymore. Just get one of these. It does a way better job. Sensorion is really good at this shit, and it has true I2C. I've got a little demo to show it off. I just think like temperature humidity sensors are just getting better and better. But this one you can see it's telling the humidity and temperature in here. It's a nice balmy indoor heating day. Luckily we don't have all the windows open right now because we're doing a show. If I breathe on it, it reacts nice and fast. But I like that it doesn't spike crazy fast. And also there's a heater element that you can turn on. So that if it is being used in a place that has such high humidity that like maybe there's water condensing onto the sensor, you can turn on the heater and the heater will help dissipate some of that heat, and you can turn it on for like, a second or a half a second or something. You can check the data sheet for the different settings. And we've got Arduino code, and this is Arduino. We also have Python code, so you can use this with your Raspberry Pi. You can use it with Home Assistant. You can use it with CircuitPython. You can do what have you. It's a great little sensor. I'm really liking Sensorion is definitely like not, they don't stay put. I mean, they've been making humidity and temperature sensors for like easily over a decade. I remember the SHT10, and they're just getting better and better. I think they've really they're finally getting like a really good system and interface for their sensors. And of course the sensor quality itself is excellent.
All right, and with that is new products.
Yay. All right, we're wrapping up right on time.
Yeah, we'll have some top secret next week.
Yeah.
This week we don't. So let's go over to Discord, where let's do some questions. Adafruit.it/Discord. Join all 27,000 of us. And let's do some questions. There was a question earlier in one of the chats. I'm going to try to find it. It was about the Cutie Pie and like memory on it or something. We were asked this before. Something about
how to put. You can solder memory on the back.
Yeah, are we going to include?
We don't include. We might eventually get around to fabbing it with it on already, but we also are kind of going to do the Cutie Pico, which that's not the name of it. It's the Cutie Pie with the RP2040, and honestly, I think like you would just go to that because it's going to have the flash memory. It's going to be much faster and like overall like a way better CircuitPython experience. So I think for now we might just I'm thinking maybe just keeping it as is. Where if you want to solder it on, you do, but to keep it low cost, it doesn't come with memory.
Okay, we could do this one. This is good maker biz question. Would you consider sharing business decisions like how Adafruit decides how much of a new board to produce in the first run, how to determine the price of the product based on cost and value, interested in learn business logic behind production choices?
Okay, very easy. So the price thing is quite simple. I take the cost of all the components, what I pay for it, and for 200 quantity or 1,000 quantity. I mean, like it depends, of course. Some things they don't make that much of because they're just more expensive or they're not that popular or they're niche. For the most part, I take the parts cost. I combine that with the manufacturing cost. If you're outsourcing manufacturing, just what's the per cost per board? You calculate that out. I don't usually include NREs, but you may want to, depending. And then I multiply by 1.5 or 1.7, somewhere in between there. That's the wholesale cost, and then multiply by 1.5 to 1.7. That's the retail cost. And so that way I can sell it, and there's two margins when you sell directly. But then if you want to sell through distributors, they get a margin and you get a margin. That way you don't go out of business. I do find people underprice more than overprice. I've rarely seen things where I'm like, wow, you really overpriced it. And often, even if I do say that they've overpriced it, they didn't.
What does NRE stand for?
It's an expense you only pay once. So usually when you fabricate, the fabrication house will say, well, there's an NRE cost, a non-recurrent cost of buying the stencil, programming the pick and place. So you may or may not include that in your initial cost. I don't. I just assume that I will recoup that over time.
Yeah, and then how many we make? We
250.
we initially make a short run, and then we'll quickly ramp up.
250.
And then we'll do thousands of thousands later. But we really like to start around 250 for
250.
On a product line, and then
Ask me again.
no, I know,
Okay.
but I'm giving the reason.
No, it's a good number. Believe me,
Yeah.
I have like studied this. 50 is
Yeah.
too small. 1,000 is too many. 250.
Yeah, you'll catch something in manufacturing sometimes, but also, you're often going to be doing revisions in electronics. So, anyways,
250.
okay.
Not
Next-
350. 250.
Yeah. Next up, how do you deal with dithering or jittery sensor data, like displaying temperature readings? I tried using a moving average, but it doesn't filter out readings, larger readings off the average.
Yeah, I mean, like, you don't have a lot of options, but basically doing a running average, which is a low pass filter, that you could always do more. It's funny is like you look. Unfortunately, everyone now knows about running averages from looking at COVID data, right? Because if you actually look at the day by day, it's very spiky, right? How many new cases? But if you do a 7-day running average, you get them. It's not perfect. You're still going to see dips, when there's a holiday or there's a snowstorm. So data doesn't come in, but you're going to see a much smoother curve. So you just have to change your running average amount. Sometimes the chips themselves have built-in filters, like some chips you can say it's an oversample filters, and you tell it take 32 samples and average them before you give it to me. So you can do that. You can do a running average. You can just take 32 samples and then average them. You can do median calculations where you throw out the top and bottom two or whatever. It's kind of unending, but yeah, you're always going to have some noise. You just have to determine how much data you want to take before that noise is going to show up in your data, and how much lag you're willing to put up with, because the more filtering you have, the more lag you're going to get.
Okay. Follow-up question. Thank you so much for this. A couple of people are launching companies soon, so they like this. But
it's a good time.
yeah. So it's 1.5x the cost for wholesale, then
Yes.
1.5x the wholesale cost for retail.
Yes.
Yeah.
That's the minimum. That gives you 30% margins.
Yeah.
If you want 40% margins, 1.66. Whether you need 30 or 40, it depends on, are you competing with something on the market and you have to adjust your margins? It's always easier to lower your price than to raise your price.
Yeah. And then Carter posted up a link to a playlist in Discord That's our Maker to Market series, where we
Yeah.
go through the process of designing Circuit Playground Express all the way
And
to.
I explain how I did the cost. I do all the
Yeah.
math and I say, here's what I'm paying. And this is where it actually, when you do that, that's when you realize that, wow, if I can save money on the materials cost, the bill of materials cost, the manufacturing cost, it ripples up quite much because you're multiplying it twice. So, every time you find a part and it saves you money because you found a cheaper part, or you were able to remove a part, that's where your cost savings are. I mean, like your bill of material, it's that's where the engineering is how can you get away with the most minimal cost of engineering, bill of materials cost engineering.
Yeah. Skirt says, I know I usually price for 50% margins on a product, so there's money to reinvest in more product.
Do it. Do 250%. That's fine. Then you double and you double, right? But so
Yeah.
1.5 is a minimum, so 1.5 to 2, right? And you have to just figure out what you're comfortable with. If there's more software engineering and more development time, you might want to have more. If this is like, hey, this was a simple board and there's not a lot of engineering that I had to do for it, and I can pump out a bunch of these and keep revising, you can go with a smaller margin. That's you and your how you want to run your business.
Yep. And so folks say it doesn't always work the way you, as you adjust your pricing to determine the price to maximize demand. Like the Cutie Pie backpack sells really well at $5. So we have someone here who they built a Cutie Pie backpack. They figured out what price point people bought it more at. So that's the price point they're
Yeah.
settling on now. Yeah, we'll do another follow-up. After the first 250, how do you determine how much you do a second run, the speed at which the first 250 sold, or another factor? So we
In
just
general-
we just made 250, we sold them.
Yeah.
How do you
So-
determine how many next?
Usually after 250, well, I think what's ironic is actually usually I do one 250 run and then I do about a 500 piece run. I tend to double. And then once I found the stability point, because the thing is you have to watch out for is that you'll sometimes get a huge spike in demand when you first make something. And then it slows down and you don't want to over manufacture. Although I rarely see that. I actually see more maker companies not manufacture enough. I have this, I want to call it a problem, but it's like we'll order something and we'll be like, yay, that worked out. We'd like to order more. And the maker's like, well, I'm not going to have anything for like 3 months. And I'm like, okay, well, that's going to be 3 months of like, you don't get any sales at all. So just be aware of like how you can make sure that you don't get stuck in a spot where you can't manufacture because you can't get parts. And that might mean buying a bunch of components ahead of time. Sometimes you can get parts and they're returnable, or like you work out with someone where like if you don't use the parts they can get it. This is unfortunately risk, and you have to, the risk is you buy stuff. This is why I like to reuse parts. Like if I go and buy 10,000 SAM D21s, that's like $20,000 of chips, and it's like 2 wheels, right? It's like nothing. The good news is that even if like the one product doesn't use it, I can use it on another one. So that's why like component sharing is important. But I see more people underestimate their manufacturing than overestimate. And when you underestimate, you lose money. Whereas if you overestimate, you're just stuck with inventory and you have to get rid of it. So I feel like there's more downside if you underestimate. That's I know it's a tactic. Well, how do you know what the amount is? People ask me, and I tell them. Like we had a maker who contacted us and said, "Well, how many do you think I'm going to sell this a quarter?" And I'm like, "I think 3,000 a quarter, because a quarter's worth is it takes about a quarter to get your inventory back up."
Yeah, also say there's it's fun to listen to like Clubhouse chats. Like I tune into some of them, and then sometimes we'll be on these. It's in the venture capital world, everything kind of changes too, because it's like fake it till you make it, and then the costs aren't, it's someone else's money that you're using. So a strategy is like, well, let's give it away for free, charge for services on the other side.
Yeah.
I would say like be careful doing hardware manufacturing when you're leaning on someone else's money, like venture capital.
Yeah.
Because it's hard. It's like the investors are going to say, just get it out to as many people. Don't really build a sustainable business because we're just going to sell this business. So it's like it's another permutation.
There's a reason why VCs don't like hardware. I mean, it's got all the downsides without any of the upsides. Like it's harder to with software. You can just compile and spin up another server, and it's it's annoying to get going, but once you get it going, it's easy to scale. Whereas hardware, it's very hard to predict. And you see this, right? Like there's toy companies when they're like, okay, is this going to be the big toy of the holiday? You, on one hand, don't, and holiday toy sales, I mean, by the way, this is an industry that you absolutely don't want to be in. I can't think of a worse industry because you have to know a year in advance. You have to get the manufacturing going because everything's done by boat. And
the other thing with toy manufacturing,
you either totally undermake or totally overmake.
Well, most of it is you're agreeing to give most of the money to the licensing that you're doing. So there's a bunch of horror stories with companies like Little Bits, or I think even Spherio. They talked about this because they made the Disney Cars toy, and they even said like, we're not going to work with Disney anymore because like Disney has all that intellectual property, and you're like, well, let's tie our hardware boat to this Disney movie. And then sometimes it doesn't work out, or they'll say like, we want most of the money from it. So that toy world is a completely different one. Follow up on this. I can answer this one. How do you get around being undercut by knockoffs of a design? Well, we do open source hardware, so we start out with the idea that our design is going to be used by someone else.
I mean, what's funny is for the Feather Pico, I say Pico, the Feather RP2040. I posted up the files before we even had the. I haven't even ordered PCBs yet.
And so here's,
you could like knock it off before I even finished it.
So one, philosophically, like knockoffs are a sign of success for us. Like we want people to make designs and learn. So can you make something that's higher quality and lower price by the scale that we do, which is we manufacture in New York City, right here, and we're competitive, even with everyone will say, okay, what about China? Try to find something that's a Circuit Playground Express, Bluefruit.
And we don't even use DRM.
Lower cost from anyone else.
And also, here's another thing. Like I know this sounds very weird, but the only thing that's cheaper about Chinese made goods or Asian made goods is manufacturing cost. What I mean is, it's not like they're getting like you can buy components from China at the same price that they are getting. I mean, the quality could be iffy, but you can get the components for the same cost. So in the end, it's what your design, it's like your design and overall experience is going to, it will allow you to have a better product than something that's just manufactured by someone, which is, it's a very vague statement, but if you're actually manufacturing, you understand what I mean? It's like, there's no magic of like, oh my God, like somebody is able to get all the components and manufacturing and everything and all the engineering done for cheaper than me. Like that it doesn't work like that. All they can do is maybe run a design, but it's everything else that you put into it that makes it good. Also, people who knock off your design, like by the way, like people who knock off my stuff, like it's weird. Like they're always knocking off the stuff from like 5 to 10 years ago, and I have to tell, like it's weird. I'm like, they're knocking off things that I've already moved on from. Like it's not anything modern.
Next up, so this is this follow-up, which is who do makers talk to at Adafruit if they're interested in carrying a product? Yeah, when you have the product ready, because we get a lot of people saying like, I'm gonna make something. We actually have the thing, even if it's prototype and you have some documentation. You can just email pt@adafruit.com. You come on show and tell and show it. We're really easy to get a hold of, but you can always email me. But just make sure you're further along, because a lot of times we get emails like, hey, I'm thinking of it. I don't have a rendering. Can you sign an NDA? All sorts of crazy stuff like that. That's not a good fit. Better make something, and we actively seek out products as well.
We won't pre-order something from you. And I gotta tell people that because they're like, "Oh, I'm thinking of doing it. Will you buy 500 before it's even done?" I'm like, "Nope. It has to exist and be sold, and then I will stock it. Just better for everybody that way."
Here's a good one. Wondering how you think the RP2040 will displace, add to, fit in the current environment of microcontrollers Adafruit. Is it good that some other board chips are no longer useful or relevant? Well, here's what I'll say. The SAMD line, the RP2040 is a welcome thing to come in because
ST too. I think this is it's good. It's good competition for ST.
Yeah, this is good news.
SAMD.
This is good news for all of you out there who make hardware, all of you who use hardware. Python is coming to millions of people. This is really good news. We've been using the SAMD line for a while. They're not going to continue to update that line. Like
Yeah, they're done, which is a shame. I
we-
really wanted a SAMD71, and
Yeah.
I asked them for a SAMD71, and they're like, we're not going to make
We
one.
want something
That would be
that's
so cool, though.
really fast that can run a scripting language. Like that's what we
Yeah.
want. Let's RAM. You know,
Yeah.
this is what we want. And so this is really good news. Also, we'll be able to do a feather line with
Look,
this.
the dominant cost of a lot of our microcontroller dev boards is the microcontroller. Look, I can't talk about what the price is likely to be for the RP2040. Only the Pi Foundation can speak to that, and they will release the pricing. But if they're going to do what they've sort of implied they're going to do, it's going to be like devastating for the rest of the industry, because they're going to be like, it's going to basically be what Espressif did to Wi-Fi chips. So Wi-Fi chips were all $20 a piece.
This is a good analogy. What did the ESP
Do to
82,
Wi-Fi, yeah.
8266 do for the entire industry? We were stuck with like $30 TI modules.
And they were so bad.
And so it was
They sucked.
really good. and here's the other thing. So when we talked to all these companies that made Wi-Fi modules
And we kept
stuff,
telling them,
we're
like-
like, check out the ESP8266. This is coming for you. And they're just like, blah blah blah. Adafruit is crazy. And what happened?
Yeah, they came for them.
Yeah.
So I don't think it's like there's not going to be. There's definitely there's some things that the RP2040 doesn't do that the SAMD51 does. You know, it's a Cortex M0, not M4, and then I think the Teen C4 uses this IMX chip. It's much faster, and like there's some things it does better, but like it is it's a nice chip, and the pricing's good. There's some things that I kind of wish it had internal flash. I think that would be really awesome, but I think they'll eventually get there. I think you can always bond in flash, right? That's what the ESP32 does. In fact, if you look at like they have the flash inside ESP32s, and if you look, it's like it's just the chip, and then inside there's another chip, and then they just wire bond it together and package the whole thing. And so like the Pi Foundation can do that as well if they want to have a flash internal microcontroller. But I think that it's good. I think it's always good for everybody. And even though I'm sure if people who work at Microchip or TI or ST are watching this and are just like, it's not good. It's not good for anybody. It is good because competition will drive these companies to do better, right? They're going to look at something and they're going to say, shit, we've been kind of churning out the same thing over and over again. And here comes this PIO thing. Here comes this microcontroller at a disruptive price. Here's what we got to do in order to stay relevant in the market. Just like the Raspberry Pi, again, single board computers. They existed before the Raspberry Pi, but they weren't under $30. And now every single board computer comes with a version that's like $35 or more, because the price point and the expectation have been set. And so there's a lot of people using other single board computers. Raspberry Pi is quite popular. They're competing, but it's a friendly competition. I think that they learn from each other, and they are building a constructive ecosystem with a lot of players. And it's great for the market, and it's great for customers. This is like beautiful.
Someone was wondering, can you invest in Adafruit? No, but purchase electronics.
You can buy something.
Purchase electronics from us, because there isn't really a better way that I know of. If someone said, well, how do you reward open source? You can donate to an open source organization. You can sponsor someone on GitHub. With Adafruit, you can buy open source hardware that funds all of what we do, including giving people great wages and retirement plans and salaries and benefits and all that stuff. But also it's funding the most amount of open source libraries that I know of for hardware. Like that's what Adafruit does.
Yeah.
So
1,400 GitHub repos.
Yeah, so that is.
I want a little crown that says the most.
It's a way to also invest in our future. I think a lot of the smart people who watch the show, if we're going to continue on this experiment called human species, we're going to want to do software, we're going to want to do hardware. I think we all believe that it's better if it's open, because we're not going to have to reinvent everything over and over, building on top of each other. So it's an investment in like all of us, and this has a business model. So if you're into capitalism, yay, you can buy something. We ship it to you. It's kind of cool.
Yeah.
Okay, other odds and ends.
Yeah, we pay our engineers to do RP2040 development.
Yep. Okay. This one's a little hard because it's predictions. When do we think there'll be a wireless RP2040?
If I had to guess, and this is, again, I know nothing, and this is just a complete guess, is given that there's already that Broadcom Wi-Fi Bluetooth chip that is on the Raspberry Pi 4 and W, they would probably make a board where the RP2040 talks to that chip. and that's the chip that does the Wi-Fi. I don't think doing wireless on chip is not easy. There's no off-the-shelf peripheral like there is with I2C and UR, where it's like Synopsys has a thing. Synopsys doesn't have a thing for Wi-Fi. So I think if they were going to do something, it'd be off chip. But again, I don't speak for the Pi Foundation, and this is just me bullshitting you. Like, this is what I would guess.
All right, really good questions today. Everyone, we do engineering questions on Desk of Lady Ada. We do them Ask Engineer. But I think one of the things that people hide is how they do business, and you get to ask Lady Ada. I think at this point, the most successful female engineer company out there. We keep asking, and especially when larger companies talk to us, we're always asking, like, do you work with any woman-owned companies? Is there anyone out there who's like us that's doing a successful hardware manufacturing company in New York City? It's definitely playing the video game on the hardest level at all times. But ask your business questions too, because we had to figure all this out on our own. We talked about it on Show and Tell or Ask an Engineer every week. We did all our Maker Business posts on our site. You can check those out. And then the Maker to Market series is another one. And we're really happy to help. It's hard. And it also is a different type of daily dedication that you have to do. It's not for everyone, but you can work at a place like Adafruit and figure out, the roles that you want within it. Not everyone's going to be Lady Ada, but not everyone needs to be. We have one so far, and so that keeps us going. Okay, I think that's going to be it for tonight. Okay, cool. Some folks are going to order stuff. Thanks. I believe that's it.
Okay.
All right, everybody. Well, thanks so much for watching the show tonight.
Thanks, everybody.
Really good questions. We're happy to help.
Yeah, I like that. You know what? It's actually very promising to see that there'll be a bunch of more businesses. I know that there in the last few years there were a lot of maker companies that not a lot, but there were a few maker companies that unfortunately didn't make it for one reason or another. They closed shop or they merged or whatever, and I would love to see
the workshop model companies. If your business was built on in-person workshops over the last year, that's been really hard.
Yeah.
Folks who have been doing physical goods or even contract manufacturing, they're popping up. And then a lot of folks have had time or some resources because they didn't travel, they didn't do a lot of things in their lives. And they also decided, well, I'm going to finally get around to that project I wanted to do. And they've been starting a lot of Tindy businesses.
I think a lot of people want to start businesses now, and it's through the summer. I think there's a lot of people who are like, I want to change my life.
Yeah. Adafruit basically got started in the 2008 recession.
Yeah, pretty much. That's when it really kicked off.
That's when we were an apartment company. I think our daily average of orders was maybe $1,000 a day, not even.
Yeah.
It was.
We gotta go get a burger.
That was it.
I was like, I can afford a burger.
And I did all the shipping, and Lamar did all the kitting.
Yeah.
And 10 years later or so.
It's a little bit more than 10 years now.
Yeah, it's a little bit more than 10 years.
It's okay. We look young.
Yeah, but that's pretty much what and that's an average amount of time to spend on something. It is a good amount of time. 2 years to grow a company isn't reasonable. You should spend a little bit more time on it.
Yes.
Okay, so that's our show for tonight. Special thanks to Jessie May behind the scenes.
Thanks, Jessie May.
Slack. Thanks everyone who was helping to run the Discords and more. And we'll see everybody next week. Thanks for supporting Adafruit.
Don't forget 250.
Don't forget what?
250.
250 is the number of boards that we make, and then we
It's true.
do more. And we'll see everybody next week. Thanks so much. Here is your moment of Zener.